Hello guys, my name is Ritvik and in this video we are going to talk about symmetric distribution and also what is the left skew distribution and what is the right skew distribution. So before we're going to deep dive into left skew distribution and right skew distribution, right? So let's discuss first what is a symmetric distribution. So let me change the color of my pen. So here as you can see that this is the right part of a distribution. So first of all, let me discuss if the shape of the bell curve. This is the bell curve, or as you can see, if the shape of any curve is going to like this, at that time you can say that this particular distribution is follow the particular column or particular distribution is look like a normal distribution or symmetric distribution. So basically what does the mean of symmetric distribution is the left side part and right side part are the same, are the mirror image of each other at that time, and we have to keep in mind our second condition to identify a particular distribution as a Gaussian distribution is that mean, median and mode are overlap each other. The value of the mean, median and mode are the same. That means a particular column or particular data follow the symmetric distribution. So now what is the need, so why we are using or why we are plotting a distribution, what is the such facts that we want to know about our data, and why we using distribution, why we are going to search about distribution, and why, what is the reason behind do all such things, right? So the question is, okay, here. So what is the need to do all such things? So first of all, when we are working with our data, at that time there is something called outlier, and if we train our model on this outlier, at that time our model will be work on a data that is not good, not good. What does that mean? So if we train our model on outlier data, so our prediction of the model is not good. Why? Because the accuracy of our model is not high. So that's why we avoid some outliers from our data, and we need to remove such outliers. To remove such outliers, we are going to do such task. We are going to do implement our symmetric distribution, and we are going to check that particular column or particular data is following the symmetric distribution or not. Now the second thing about this distribution is this particular distribution follow 68, 95 and 99.7% rule. What does that mean? So in the first standard deviation of this distribution covers 68% of data point. The second standard deviation of this distribution is cover 95% of total overall data sets. If we talk about the third standard deviation, then we can say that if a particular column or particular data follow a Gaussian distribution or normal distribution, or we can say as a symmetric distribution, if they follow either one of three distribution, then it in the third standard deviation it cover all 99.7% data. Whatever data left after all such things, we can treat as an outlier, right? We need to simply remove from our data set. We are not going to train our model on this data set, right? So whatever after the outliers, whatever data we have left, we are going to train our model on the data. So this is the use of symmetric distribution and why we are worrying about symmetric distribution or left skew or right skew distribution, right? Okay, now the second question, what is the left skew distribution and what is the right skew distribution? So here we are going to talk about left skew distribution and right skew. So first talk about the left skew. So basically left skew means the tail of the left side is long. If we have a particular distribution like this, that means the tail of the left side is longer. That means we have a value of mean, median, and mode like this. Mean is quite lower than median, and median is quite lower than mode. So that's why we need to check our data first. If we have a left skew distribution, then we are going to try it to convert into symmetric distribution with some techniques. We are going to discuss such techniques in our next video. Okay, now if the now the question is, what is the right skewed distribution? Suppose we have a distribution in which the right tail of the distribution is quite long. Tail is long, right? So just give me a second. Like this, our graph is gonna like this, right? So this distribution is right skewed or positive distribution. The value of mean, median, and mode are gonna like this. Clear? Now suppose what are the example of left skew distribution and right skew distribution? So when we talk about the left side distribution, so at that time we can say that the salary of the employees, the particular company. Okay, so probably we can know. So in the left side distribution, okay, we can say that salary of employee is the example of right skew distribution. This is the example of right skewed or positive distribution, because most of the person's salary is ranging between, as a fresher, most of the person's salary is ranging between 25,000 to 50,000, whereas there are some minor cases in the companies of there are some minor cases where the employee salary is ranging between 101k to 250k, right? So this is the example of right skewed distribution or a positive distribution. And if we talk about the left skewed distribution, the what is the example for that? So in this case we have a example of a death, right? So suppose we have a function. Here we are going to talk about left skewed distribution. So in the left skewed distribution, we are take as an example of dead people. So most of the death occurred in natural death. We are talking about natural death. So most of the death is occurred in when the age 70 to 80, range between 70 to 80. Most of the people are going to die, which is by natural, right? Which is the natural cause of the death, right? So this is, and there are very less people who are going to die between 2 years to 70 years. So at that time we can distribute, at that time our graph, if we plot our graph, then this is gonna be like left skew distribution, right? So now the question is, we have another such plots called box plot. right? And if we want to plot, so is there anything that we can identify the distribution? So with the help of box plot, we can easily identify that a particular column or particular data follow which distribution, right? So let me plot a graph first. So here we have like this. Okay, so this is the median part, right? And okay, so this is the upper side and this is the lower side, right? Okay, and this is the main part. So if this is represent a median, this line, this is upper whisker and this is a lower whisker, right? This is a Q1 and this is a Q3, quartile 1 and quartile 3. So our median is on the center of this box. That means we can say that this particular column or particular data follow the symmetric distribution. Symmetric distribution. Now, if our graph like this here, the tail is left side tail is quite longer. So here is a quiet Q1, sorry, this is a Q1, this is a Q3, this is the upper whisker, and if we have a graph like this where the upper whisker length is quite short rather than a lower whisker, right? So at that time we can say that our graph is follow the left skewed distribution, right? So now we have a graph like this, and whereas our lower whisker is quite short instead of, okay, and here we have upper whisker is quite longer, upper whisker. That means our graph is followed right skewed distribution, right? So this is all about distribution. We in this video we have learned how to plot symmetric distribution, what is the use of symmetric distribution, what is left skewed distribution and right skewed distribution. Also we get that how we can plot, how we can identify distribution using a box plot. So this is all about Gaussian distribution. Sorry, this is all about symmetric distribution, right? So thank you for watching.